Welcome to the GeoMethod channel. Today we are solving another interesting geometry problem. Here is today's challenge. Can you find the area of green shaded triangle? Take a moment to study the figure. Then let us uncover the key geometric ideas that make the solution click. Here is trapezoid ABCD. The left side AB is parallel to the right side CD, and the corner at B is a right angle, so the horizontal side BC is the height between the two parallel sides. The diagonal AC cuts the trapezoid into two triangles. The green triangle ACD on the upper right is the one whose area we want. The other piece is the white right triangle, ABC, with its right angle at B. We know the most about this triangle, so we start there. We are told the white triangle ABC has area 54, and the horizontal leg segment BC equals 9. From these two facts, we can find the other leg. The area of a right triangle is 1/2 the product of its two legs. Here the legs are segment AB and segment BC. So the area is 1/2 times segment AB times segment BC. Put in the area of 54 and the leg segment BC equal to 9. That gives 1/2 times segment AB times 9 equals 54, an equation with only segment AB unknown. Multiply both sides by 2 to clear the 1/2. Now segment AB times 9 equals 108, which we will divide to isolate segment AB. Divide both sides by 9. Segment AB equals 108 over 9, which is 12. So the left side AB is 12. Now turn to the green triangle ACD. Take its base to be the right side CD. Then its area is 1/2 times segment CD times the height from A across to that base. Because A lies on line AB and segment AB is parallel to segment CD with segment BC perpendicular to both, the height from A to the right-hand line is exactly segment BC, which is 9. So the green area is 1/2 times segment CD times 9. Everything now comes down to one missing length, the right side CD. The two blue sides, segment DA and segment CD, carry equal tick marks. So triangle ACD is isosceles with segment AD equal to segment CD. This equal length clue is what fixes segment CD. To use that clue, draw a perpendicular from A straight to the right onto the line through C and D, meeting it at a new point F, and draw the segment AF. This creates a right angle at F. Our first insight is this: a hidden rectangle transfers both dimensions. Look at right triangle AFD. Its horizontal leg segment AF is 9. Its vertical leg segment FD is segment CF minus segment CD, that is 12 minus segment CD, and its hypotenuse segment AD equals segment CD by the isosceles clue. By the Pythagorean theorem, the hypotenuse squared equals the sum of the legs squared. Since the hypotenuse is segment CD, we get segment CD squared equals 81 plus 12 minus segment CD squared. Expand 12 minus segment CD squared into 144 minus 24 segment CD plus segment CD squared. Adding the 81 to the 144 gives 225, so the right side is 225 minus 24 segment CD plus segment CD squared. A second insight now finishes the structure. Equal hypotenuse and leg cancel the squares. Move 24 segment CD to the left and divide. Segment CD equals 225 over 24, and canceling a common factor of 3 gives 75 over 8, or 9 3/8. Substitute this segment CD back into the green area. It is 1/2 times 75 over 8 times 9. First, multiply 75 over 8 by 9 to get 675 over 8. That is base times height, still to be halved. Now take 1/2 of 675 over 8, which is 675 over 16, about 42.2. So the answer is 675 over 16. That completes the solution. A good geometry problem often has more than one beautiful solution. If you see a genuinely different construction, a high-level idea that leads to another solution, or a thoughtful adaptation of an existing method, share it in the comments. Even a rough idea is welcome. A sketch of the key move is enough. We greatly appreciate these contributions. With your permission, we may feature the approach in a future Viewer Solutions episode and acknowledge you by name or channel handle. Thanks for exploring geometry with GeoMethod.